Greetings to everyone watching this on the internet. This is Group 7, and in this presentation, we're going to go over Chapter 3, which goes into more details about the second way or the principles of feedback. Now, in the first way, it talked about the steps in the value stream from the development teams to go to the operations and the deliveries to the customers. Now, the second way deals with principles that enable the fast and constant feedbacks from a right to left perspective at all the stages of the stream, meaning that all the feedback from the operation side goes back to the initial development cycle cycle of the process. And then the goal for this is to be able to create safer and more resilient systems of work because in the past development teams would just create the product itself, send it out to delivery, and then either and then at that time they would either just work on something else or they would try and fix whatever defects come back from the customer side. However, in the second way, they want to be able to get the feedback to the back to the development team a lot faster. That way, it can be uh, that way it helps us detect and remedy the problems at a quicker rate before they become total catastrophes. This sort of method helps creates organizational learning that can be implemented into future works or other projects. And then if the if the problem was found at an earlier rate, then it can be fixed in a smaller, cheaper, or easier method than traditional. Now, in the past, the word failure was seen as sort of a negative term that if you fail, then that's a bad thing. But what's nice about DevOps is that failure is just another opportunity of learning. When something goes wrong, you just learn about it and then you try not to make that same mistake again in the future. Now, whenever you deal with more complex systems that have a high degree of interconnectedness, there is always a lot of pieces to do. It's like comparing building a house to a skyscraper. Sure, a house is easier and it's only just one floor, but with a skyscraper doing with multiple floors, there could be a lot of parts moving, which would also produce a lot of problems down the line. And this the system level behavior cannot be explained simply in terms of the components alone. There nothing is ever the same geographically. From for example, like if someone was living up north in the mountains and they were building something, it would be completely different than what was built like on a shoreline in a hot tropical area. Now, Albert Einstein's definition of insanity is uh, do, doing something exactly the same and expect something different. Now, Dr. Decker said that doing the same thing twice will not predictably or necessarily lead to the same results. And this is a very common thing that even though everything checks out fine and it's been checked by all the quality testers and it passed through all the inspections, that does not really guarantee that a catastrophe would not happen. In fact, businesses realize that failure is an inevitability. It happens to everyone. There was Apple's iPhone 4 that was really bad. And then Samsung had the Galaxy S Note 7s that blew up, and Microsoft's operating system, Windows 8. Those were terrible products from the beginning. But be, because of those inevitabilities, we must create a safe system of work. And in the past, their employees were terrified of errors because when something goes wrong, they are somewhat responsible for it, and that would later result in either punishment or worse, termination. But when when these errors do occur, they encourage the employees to not fear about what's going to happen, but to focus on resolving the issue before it gets worse.
Continuing with working safely within complex systems, Dr. Stephen Spears stated that designing perfectly safe systems is likely beyond our abilities, but we can make it safer to work within complex systems when we follow the four conditions. They are: first, complex work is managed so that problems in design and operations are revealed. Second, problems are swarmed and solved, giving everyone new knowledge in small time frames. Third, new local knowledge is exploited globally throughout the organization. And lastly, leaders create and enable other leaders within the organization who also resemble and grow these qualities. Another important system in the second way is to see problems as they occur. In a safe system of work, we must constantly test our design and operating assumptions. Our goal is to increase the information flow from as many areas as possible, making things happen sooner, faster, cheaper, and with as much clarity between cause and effect as possible. Every work operation is measured and monitored, and any issues are quickly found and handled with very little hesitation. In the technology value stream, we often get poor outcomes because of the absence of fast feedback. Proper feedback loops prevent reoccurring problems. Swarming problems is another major way to prevent reoccurring issues. It is not sufficient to simply detect when the unexpected occurs. When an issue arises, it is best to swarm the problem with all hands on deck and solve the issue as quickly as possible. The goal is to contain problems before they become catastrophe, then diagnose the issue so that it does not occur again. Swarming is necessary for the following reasons. It prevents the problem from progressing downstream. It prevents the work center from beginning new work while issues are still in play. And if the problem is not addressed, the work center as a whole can have the same problem in the future.
So, as opposed to outsourcing quality control, it's best to keep the bug searching and quality assurance in the area that the program is being developed in. This will help ensure that, because as something goes down the chain, more bugs will be introduced, and it's just easier to tackle them before it gets too out of hand. Um, Peer reviews help take control of proposed changes to make sure that yes, this will actually do what we want it to do in the code, and we'll have a good result. So then the QA shouldn't be left to people to do as much as can. Should be automating it as much as possible, just to reduce the amount of time spent on those tasks and keep it working right and more efficient. So developers share the responsibility for the quality of the systems as they continue and build something and figure out the bugs that they're encountering. It'll accelerate their learning process and improve the eventual final product. So go to the next slide. We want to enable optimization for the downstream work. What this means is that as we higher upstream solve the issues and take care of the bugs and patch things around, that'll be less bugs going downstream, which means less time it takes to, eventually get the product out. So the two types of customers: the external customer, which is the one paying for the service, and then the internal, which should be pretty much the next people downstream that are going to be handling the project. The most important part is the one next after you, because they're the ones that are going to be handling it next and processing and handling that product. So this will result in quality at the source, where things are taken care of as they're progressing down the chain and not getting into big spaghetti code messes. So downstream work centers can focus on different things such as performance, stability, and security. Just some of the things they can work on and focus on to improve and develop for the eventual end user. Then to the conclusion. So overall, fast feedback is key to achieving quality, reliability, and safety in the value stream of technology. So this is done by recognizing problems as they occur and swarming them as quick as you can to resolve those issues, which would be taking care of it at the source. And then because of this, it results in new knowledge for us as we realize, oh, hey, this will cause these issues, so we can prevent that going forward. And yeah, if anyone has anything else to add, go for it.
All right, so that's it for the second way. We got to remember that fast feedback is key to achieving quality, reliability, and safety in the technology value stream. This is done by recognizing problems as they occur and swarming them so that we can solve them quickly. This results in new knowledge base as well as pushing quality closer to the source, which optimizes for downstream work centers. Thanks, everyone.